Okay, topic number 7 is finding the distance between 2 points. And sometimes it's very easy to do, such as this horizontal segment AB. How far is it from A to B, or what is the length of the segment? It is 3 spaces, 0, 1, 2, 3. So the answer for the length of AB is it's 3. To find out the length of CD, that is a vertical segment. That is something you can count. 1, 2, 3, 4, 5, 6, 7, 8. So CD has a length of 8. Now, when you get onto diagonal lines, it is not correct to try to count that from E to F. Instead of counting, what we do use is we use a horizontal segment and a vertical segment to make a right triangle, and then we can use the Pythagorean theorem to find the missing segment's length. So suppose we want to use the Pythagorean theorem to find out how far it is from E to F. We'll call that C, that is our hypotenuse. We can count how far it is on both legs of that triangle. This is 1, 2, 3, 4 spaces. And in terms of the height of that triangle, that is a height of 1, 2, 3, 4, 5. So I can use the Pythagorean theorem to figure out how far it is from E to F. So one of the legs of the triangle is 4, the other one's 5. If I use the Pythagorean theorem, I'd get 16 plus 25 is equal to C squared, and 41 is equal to C squared. Now to find out what C is, I'm going to need to use a square root to get there, which will give me an answer that's in between 6 and 7 for how long it is from E to F. I can use a calculator to get an estimate of how far it is. And if I type it in, I end up getting that C is approximately equal to 6.4. And if you look at the picture, it does look appropriate that this would be slightly bigger than 5, and it's the hypotenuse, so it has to be longer than 5, and 6.4 sounds about right. Now this answer here, radical 41, that is in radical form. As it turns out, since 41 is a prime number, that cannot be broken down any further. So this is in simplest radical form, and it's the exact answer, while this answer here is an approximately equal sign, so it's approximately 6.4 if I rounded to the nearest tenth. All right, here's an example of how we use the distance idea to determine some information. For this particular question, suppose that it asks me to prove that ABCD, quadrilateral ABCD, is a, well, what kind of shape does it look like? Prove that it is a rhombus. Okay, a rhombus has 4 equal sides. So what I can do to find out how long each side is I can make a right triangle on each of the 4 sides and figure out the length using a squared plus b squared equals c squared. So let's start with this white triangle here. If I'm counting the height and the base of this right triangle, I've got a height of 1, 2, 3, 4, 5. And I have a base that is 1, 2, 3, 4, 5. If I also check the triangle that is in the lower left-hand corner, and I measure the sides of the height and the base, I also get 1, 2, 3, 4, 5 for the base, and the height is also 1, 2, 3, 4, 5. So what I've got now for sure is that BC is definitely equal to AD because I'm using the same right triangle to figure out the missing side. Both of those hypotenuses are the same. So I would use 5 squared plus 5 squared equals c squared to figure out the length of the hypotenuse. So I get 25 plus 25 is c squared. So 50 is c squared, which must mean that c is equal to radical 50. Radical 50 can be put in simplest radical form. And let's talk about that, breaking down radical 50 into simplest radical form. Well, radical 50 breaks down into 2 times 25, and I can use that information to break down radical 50. Radical 50 is the same thing as radical 2 times radical 25, which is equal to radical 2 times 5, or 5 radical 2. You could also break down radical 50 using a factor tree, which I know a lot of teachers and students like to do. I'd rather just handle it this way by using some perfect squares. But if you have to break down radical 50, you could also break it down into 2 times 25 and 5 times 5 when you break down the 25. And you stop when you hit prime numbers. And then the rule is for every 2, 1 comes out of the radical, and that'd be another way to get the simplified radical version of the answer, 5 radical 2. All right, so a lot of writing there, but basically it's the same work twice over to find 2 sides. If I had to find, I still have to find how far it is from D to C and A to B. And the good news is I'll be using the same triangle to do both, accomplish both tasks. This is 1, 2, 3, 4, 5, 6, 7. 7 by 1. And this triangle is also 1 by 7. So to find out these 2 missing sides, which I'll nickname x, I would use Pythagorean theorem again. And it would be 7 squared for my A plus 1 squared for my B equals x squared. I get radical 40. I get 49 plus 1 is 50. So 50 is x squared. And that must mean that x is radical 50, or 5 radical 2. So I can actually list that down too, that AB is the same as DC, that they're both 5 radical 2. And in fact, all the sides are radical 50 long. So since this is true, since all sides are equal, it is a rhombus. And this work's really not complete unless you actually use some words to explain what you just figured out. Alright, that last example could have been a little bit spooky to take a look at, and I certainly didn't mean to scare you. So let's just review one more time with one more line. If I have these 2 points here, you can find out the distance between those 2 points by using the Pythagorean theorem. This is 1, 2, 3. It's countable. And this base of the triangle would be 1, 2, 3, 4, 5, 6. So if I have to find a missing length that's diagonal, I would just rely on using the Pythagorean theorem. So I'm getting 3 squared plus 6 squared is c squared. 9 plus 36 is c squared. So C would be equal to the square root of 45 when it's all said and done. And that would be an exact answer. If they asked for the answer in to the nearest tenth, you would just take the square root of that on your calculator and get an approximate answer. The approximate answer is about 6.7 if you use the calculator, which matches what it looks like in the picture, that this would be about 6.7. And then to rehearse the simplified radical form one more time too, if I had radical 45 and I was asked to break it down, you could break it down into 5 times 9. And then if you're slick, you would just stop right there and say, well, the square root of 9 is 3, so the answer is 3 radical 5. But if you're not that slick, if you want to take it on a safe way or some way that you've known before, you can break the 9 even further down. And then the rule is for every 2 that are the same, 1 comes out. And the 5 doesn't have a partner, so it would be stuck under the radical. Of course, there's another way to figure out the answer too that does not involve the Pythagorean theorem, that is using the distance formula. And even that's not something I really preach too much about, because the formula for the distance formula is a bit tedious to work with. You're subtracting the x's and you're squaring, plus the difference between the y's squared. So you'd have to actually have to have the points coordinates to begin with. So if you wanted to use the distance formula to answer this question, you'd have to know those coordinates as -2, -4. And also you'd have to know the coordinates of the other endpoint, which looks to be 1, 2, 3, 4, 1. If you're using the distance formula, which I think is still great, although it's a little bit more clumsy to work with than the Pythagorean theorem, the answer would look like this. Subtracting the two x's from each other would be 4 take away -2 squared, plus subtracting the two y's from each other, 4 minus 1 squared. You end up getting the same numbers because this is basically a version of the Pythagorean theorem. You get the square root of 6 squared plus 3 squared, which ends up being radical 45. A more complicated way to get there, and nice to use if you don't have a sheet of graph paper, or if the coordinates are impressive in some way, they're very large, or maybe involve some decimals, the distance formula might be the way to go. But for my money, the Pythagorean theorem is something that's definitely easier to remember and pretty easy to use.